Hello students, in this video we study the solution of first order differential equation, but its degree is not 1. So degree is not 1 means the index of highest order derivative is more than 1, 2 or 3, and first order means highest order derivative which is exist in given differential equation is of order 1. In general, the ordinary differential equation with the degree not equals to 1 is p raised to power n plus p1 p raised to power n minus 1 plus p2 p raised to power n minus 2 plus so on pn equals to 0. This is general equation of order 1 and degree not equals to 1. Here the small p is represented by dy upon dx. It means this is what dy upon dx raised to power n. The index of dy upon dx is n in this term. Here p1 into p raised to power n minus 1, that is dy upon dx raised to power n minus 1. Highest order derivative is first order only and its highest power is n, so this is of degree n equation. Here the coefficient p1, p2, pn are some function of x or y. Normally, to solve this equation we use three approaches in different conditions. The first approach is we solve this equation by the method solvable for p. Solve for p this equation. Other two methods are we solve this equation for x and solve this equation for y. One by one we discuss this method. So first we discuss the first method, which is solvable for p. In this method we replace given equation with two equations of first degree and then we solve them. So let's try one example, which is p square plus 2py cot x is equals to y square, or we can rewrite it as p square plus 2py cot x minus y square is equals to 0 as per general equation. Right hand part is 0. So it can be written as p square plus 2py cot x minus y square equals to 0. Now when we solve it for p, this is a quadratic equation. This is a quadratic equation, and so that we can find two equations. If it is of more degree, if it is of third degree or fourth degree, then we replace given equation with three equation or four equation. So we can find the value of p using the formula b square minus 4ac upon 2a. So p is equals to, here a is 1, from here a is 1, b is 2y cot x and c is minus y square. So minus 2y cot x plus minus square root of v square, that is 2y cot x is square, 4y square, 40 square x, minus 4, a is 1 and c is minus y square, so plus 4y square. From here taking 4y square outside, so out of square root sign we have 2y, so these two cancel out from numerator and denominator, so we have p is equals to this, taking y outside, so here remaining term is minus cot x plus minus square root of cot square x plus 1, or we can rewrite it as p is equals to y minus cot x plus minus cosec x, as 1 plus cot square x is cosec x. Now as we know, p is what? Dy upon dx. So replace p with dy upon dx. We get dy upon dx is equals to y into minus cot x plus minus cosec x. So from here we can get two equations. One is dy upon dx is equals to y minus cot x plus cosec x. And second equation is dy upon dx is equals to y minus cot x minus cosec x. One by one we will solve it. Solve these equations. So from equation 1 we have dy upon dx is equals to minus y cot x minus cosec x. So we can write cot x as cos x upon sin x and cosec x as 1 upon sin x. Taking LCM as sin x, we get here cos x minus 1. So multiplying this minus sign, we have 1 minus cos x upon sin x. Now we can replace 1 minus cos x as 2 sin square x by 2 using the formula. As we know, sin square x is what? 1 minus cos 2x upon 2. If angle is half x by 2, here 1 minus cos x. So 1 minus cos x is 2 sin square x by 2. Similarly, sin x is what? 2 sin x by 2 cos x by 2 using this formula. Now here sin square x, from sin square x by 2, 1 sin x by 2 and in denominator sin x by 2 cancel out. So it will remain dy upon y is equals to sin x by 2 upon cos x by 2, which is tan of x by 2. Now we will integrate it both sides. So we get 1 upon y, its integration is log y is equals to 2 log sec x by 2, as integration of tan x by 2 is log sec x by 2, and then x by 2 its coefficient 1 by 2, so divide it by 1 by 2, so we get 2 log sec x by 2 plus log c, which is an arbitrary constant. Or we can rewrite the right hand part as taking using the property of log a plus log b is log ab, and 2 log a will become log a square, so log c sec square x by 2. Or we can write it as y is equals to c sec square x by 2. Now we will use second equation, which is dy upon dx is equals to minus time y cot x plus cosec x. Again rewrite cot x as cos x upon sin x and cosec x as 1 upon sin x. And after taking LCM, we get 1 plus cos x upon sin x. 1 plus cos x is what? 2 cos square by x by 2. Using the formula cos square x is equals to 1 plus cos 2x upon 2, we get 1 plus cos x as 2 cos square x by 2. And sin x is 2 sin x by 2 cos x by 2. 1 cos x by 2 in numerator and denominator cancel out. Remaining term is minus cos x by 2 upon sin x by 2, which is whose integral. Now we will integrate it. So integration of left hand part is log y, and integration of right hand part is minus 2 log sin x by 2 plus log c. Or we can rewrite it as y log y is equals to log c 1 upon, it becomes sin x by 2 raised to power minus 1. It means 1 upon sin x by 2, which is cosec x by 2, or cosec square x by 2 using the property of log m log n is log n raised to power m. So it becomes y is equals to c cosec square x by 2. Hence general solution for this problem is first solution, which is y minus c sec square x by 2 into second y minus c cosec square x by 2 is equals to 0. This is general solution for given equation. Now we solve one more problem. X square dy upon dx whole square. Here dy upon dx is what? P. So we can rewrite it as x square p square also, or x square dy upon dx whole square minus 2xy dy upon dx plus 2y square minus x square is equals to 0. From here we can find the value of dy upon dx, which is p actually. So its value is equals to, here b is minus 2xy, a is 1, and c is 2y square minus x square. So dy upon dx is equals to minus b. So minus minus plus, it becomes 2xy plus minus square root of 4x square y square minus 4 a is x square into c. C is 2y square minus x square. So it becomes minus 4x square 2y square minus x square. Now we will simplify it. So from here, taking 4x square outside the under root sign, so here outside of this square root sign, we have 2x. So taking 2x in numerator and denominator common, so in numerator we have y plus minus square root of x square minus y square, whereas in denominator we have x only. Now we can rewrite it as dy upon dx is equals to y upon x plus minus square root of 1 minus y square upon x square. This is a differential equation of order 1 and degree 1 also. And also the given equation is what? Homogeneous. first order ordinary differential equation. So to solve first order homogeneous ordinary differential equation, we are to replace dependent variable, which is y here. We are to replace y with vx. V is some another dependent variable. X is independent variable. So when we choose y is equals to xv, dy upon dx become v plus x dv upon dx. So replace dy upon dx and y in this equation. We get v plus x dv upon dx is equals to v plus minus square root of 1 minus v square. Or we can rewrite it as x dv upon dx. These both we cancel out. So x dv upon dx is equals to plus minus square root 1 minus v square. Or we can rewrite it as dv upon square root 1 minus v square is equals to plus minus dx upon x. Now from here we are to integrate it. We can separate both equation, or we can directly integrate both equation together. So integration of 1 upon root 1 minus y square, it gives us sine inverse y is equals to plus minus log x plus minus log c. So finally we get sine inverse y is equals to plus minus log c by cx, or this is final general solution of given problem. Now we will solve one more problem, which is p square y square cos square alpha minus 2pxy sin square alpha plus y square minus x square sin square alpha. Here we are to take p and y together, so it becomes py whole square cos square alpha minus 2x sin square alpha py plus y square minus x square sin square alpha. From here we can find the value of py. So py is equals to 2x sin square alpha plus minus square root. Here a is cos square alpha, b is minus 2x sin square alpha. So b square, it gives us 4x square sin 4 alpha minus 4ac. A is cos square alpha, whereas c is y square minus x square sin square alpha. So we get 4x square sin 4 alpha minus 4 cos square alpha y square minus x square sin square alpha upon 2 cos square alpha. When we simplify it, so from numerator and denominator taking 2 outside, so when we take 4 outside from square root sign, we can take 2 common in numerator as well as 2 is in denominator, so 2 in numerator and denominator cancel out, and divide numerator with cos square alpha. We get x tan square alpha plus minus x square sin 4 alpha upon cos 4 alpha. When this cos square alpha move into under square root sign, it becomes cos 4 alpha. So sin 4 alpha upon cos raised to power 4 alpha gives us tan raised to power 4 alpha minus cos square alpha cancel out, and this cos square alpha become cos 4 alpha. So we have here 1 upon cos square alpha in square root sign, which become sec square alpha into y square minus x square sin square alpha. So from here, taking x square tan 4 alpha, and this becomes minus sec square alpha and sin square alpha, it becomes tan square alpha. So here we have plus x square tan square alpha. So from first and third term, we can take x square tan square alpha common. So in first term we get we have tan square alpha, and in third term we have 1 only. So it becomes x square tan square alpha into 1 plus tan square alpha, and second term which is minus x square alpha y square. Tan square alpha plus 1 is sec square alpha. So taking outside sec square alpha, we have sec alpha outside of the square root sign. So this equation becomes py is equals to x tan square alpha plus minus sec alpha square root x square tan square alpha minus y square. Now taking x tan square alpha into left hand part, it becomes py minus x tan square alpha, which is equals to plus minus sec alpha square root of x square tan square alpha minus y square. Now we can write P as dy upon dx. So after simplification it becomes y dy minus x tan square alpha dx is equals to plus minus sec alpha under root x square tan square alpha minus y square into dx. Now divide whole equation with the square root of x square tan square alpha minus y square. So in left hand part we have plus minus y dy minus x tan square alpha dx upon square root x square tan square alpha minus y square. When we differentiate x square tan square alpha minus y square, we get 2y dy minus 2x tan square alpha, which is in numerator. So this term x tan square alpha, taking minus outside from here, it becomes x tan square alpha dx minus y dy upon square root x square tan square alpha minus y square. It can be written as derivative of square root of x square tan square alpha minus y square. This whole term x tan square alpha dx minus y dy upon under root x square tan square alpha minus y square can be written as derivative of under root of x square tan square alpha minus y square. Now we will integrate it both sides. So we get minus plus square root of x square tan square alpha minus y square is equals to minus x sec alpha. As we are to integrate it with respect to x, we get minus x sec alpha plus c. Now we will square both sides. So we get square of minus x sec alpha plus c. Its square will be x square sec square alpha minus 2cx sec alpha plus c square, and taking this taking x square sec square alpha into left hand part, we get x square tan square alpha minus sec square alpha. Sec tan square alpha minus sec square alpha is minus 1. So it becomes minus x square minus y square plus 2cx sec alpha minus c square. Or it can be written as in the form x square plus y square minus 2cx sec alpha plus c square equals to 0. So that's all about how to use the solvable for P method to solve first order but not of first degree